You know, the entire fight against cancer has pretty much always been reactive. We wait for a tumor to show up, and then we attack it. But what if we could get ahead of it? What if we could actually stop cancer before it even becomes a physical thing? Well, that's the incredible promise behind this concept, the El Morabea system. It's an integrated scanner and repair unit that's aiming to completely rewrite the rules.
And this really lays out the fundamental shift we're talking about. On the left, you've got business as usual. Wait for a physical tumor, then react. But on the right, that's where things get wild. Instead of looking for the biological shape of cancer, this system looks for its energetic signature. It's targeting the unstable energy in a cell that exists before a tumor even thinks about forming. It's a total paradigm shift.
So the big question, right, is how on earth do you target a threat that isn't even physically there yet? Well, the answer is to completely change the battlefield. You move from the world of biology to the world of physics. We stop looking for abnormal shapes, and we start looking for the unstable energy that causes them. And that brings us to this absolutely central concept, the maturation point. Now, this isn't a point in physical growth. It's a moment in time. It is the exact instant that a cell gets so full of unstable, high-potential energy that it flips the switch and starts turning malignant. And the key here, the whole game, is that this happens before any physical tumor forms. That specific moment, that's the new bullseye.
This really gets to the core of it, doesn't it? We do not just look for shape, we look for energy. But okay, how do you make sense of what must be just chaotic energy signals coming from billions of cells? That's where the AI steps in. And honestly, the best way to think about it is like noise-canceling headphones for your biology. It takes this incredibly messy, chaotic energy signal, this biological chaos, and it just filters out all the junk, leaving behind a crisp, stable signal that becomes the diagnosis.
Okay, so how does this all actually work in practice? Well, the system has this really elegant four-phase process. You can think of it as a complete energy audit of the human body. So let's pop the hood and break it down. All right, here's our roadmap. First up, the body gets prepped with a bioconductivity layer. Then, it's into the tunnel scanner. After that, we have the regenerative energy bank, which is super cool. And finally, the system runs a 5-layer DNA filtration to actually repair the damage. Let's dig into each one.
So phase 1 is all about prep work. Here's the problem. If cells are dehydrated or resistant, they can completely hide the super subtle electrical signals from free radicals. So to fix that, the patient gets a specialized electrolyte solution. This basically turns the entire body into a highly conductive salt bridge, making it way easier for the scanner's energy to flow smoothly and find what it's looking for.
Now, the scanner itself is pretty unique. Instead of just blasting energy from all over, which can create interference and messy signals, it uses a one-source, one-sink design. An energy pulse goes in one end and is collected cleanly at the other. This creates this beautiful, smooth, laminar flow of energy through the body. Think of it like a calm river instead of choppy ocean waves. It's absolutely crucial for getting a clean, precise reading.
Let's talk a little physics, because this is the clever part. Free radicals, things like superoxide, are naturally negative. They have extra electrons. So the system sends a fully positive energy pulse through the body. And, you know, just like with magnets, opposites attract. The machine then tracks exactly where that positive energy gets soaked up or neutralized by those negative free radicals. And boom, you've just mapped out a potential energy breach, which is the first sign of trouble before DNA even gets damaged. But here's the thing. That raw signal is unbelievably noisy and chaotic. This is where the AI becomes the absolute hero of the story. It acts as what the system calls a digital spin trap. It takes that messy, high-energy signal and essentially cools it down through layers of deep learning, locking onto a stable, clear diagnosis. It's the universal translator, turning the language of physics into the clear language of medicine, and confirming that a cell has hit its maturation point.
Phase 3 is just brilliant engineering. As that energy pulse travels through the body, any of it that dissipates gets captured by these supercapacitors that line the tunnel. This energy isn't wasted, it's stored in a condenser system, and then, get this, it's used to power the next pulse. It's basically a self-powering, zero-waste loop of diagnostic energy. So clever. And finally, after you find the problem, you gotta fix it, right? Phase 4 is the repair shop. It uses a 5-layer filtration system to fix the DNA itself. A great way to think of it is like spell-checking your genetic code. It hones in on specific DNA bases, the fundamental building blocks like adenine and cytosine, which are the ones most likely to get damaged by free radicals. By fixing these little typos, it aims to restore the cell's original genetic blueprint and stop cancer dead in its tracks. Okay, I know what you might be thinking. This all sounds a little bit like science fiction, maybe something out of Star Trek. But actually, every single piece of this system is grounded in real, established science. This next slide shows how these futuristic ideas are connected to research that's happening right now.
So take a look. Each PACE has a scientific counterpart. The scanning method? It builds on principles from tumor-treating fields, which are already FDA approved and used to fight cancer. The DNA repair part? It leverages the same kind of thinking behind revolutionary tech like CRISPR. So the real innovation here isn't inventing every little piece from scratch, but brilliantly integrating all these proven concepts into one predictive powerhouse.
So, what's the big picture takeaway here? What does this all mean? Well, this isn't just about a fancy new machine. It's about a potential massive shift in how we approach medicine altogether. We're talking about moving away from treating a disease that's already taken hold to preventing it from ever reaching its final physical form. And this is the ultimate goal. This says it all. The mission is no longer to just treat cancer. It's to get in there, control the unstable energy inside a cell, and prevent its maturation from ever happening. I mean, that is the very definition of proactive, predictive medicine. Which really leaves us with this one last incredible question to think about. As we get better and better at understanding the universe on a fundamental level, could this shift in focus from the biology of a disease to the actual physics of the energy that creates it, could that be the key that finally unlocks a future of truly preventative medicine? It's an amazing thought.